Hi everyone, welcome to practice report number 15, control environment with the temperature sensor and actuator fan. We are using the same three libraries, the STD-Logic 1164, the STD-Logic Awrite, and the STD-Logic Unsigned. Our entity's name is temperature control. We have three inputs and one output. The first three inputs are clock, reset, and sensor temperature. And our output is ventilador, that is the fan. And that's everything for the entities. Now the architecture behavioral of temperature control. We have our critical temperature, that is a constant, and our signal, that is the actual temperature, that is the one that is going to be measured by our sensor. And we have the begin. Our process has the parameters of clock and reset. If reset is 1, then actual temperature is going to have 0. This is just for initialization of the actual temperature, and is going to deactivate the fan. We're using a 1 here because our relay model works on negative logic or inverse logic. So a 1 is actually a 0 because we needed to send a 1 in order for the fan to stop stop working. So that's why we're using a 1 there. And well, else if rising edge, the parameter is clock. This is going to update the actual temperature of our sensor. And then we have the fan control. If temp actual is bigger than critical temperature, then it's going to turn on the fan. So we're sending a 0 there. And else is going to turn off the fan. And that's everything for the VHDL code. Now I'm going to explain really quick the code for the Raspberry Pi Pico using Tony. Hi everyone, now we are on the Tony for the Raspberry Pi Pico. And the Raspberry Pi Pico, we're using it for measuring on real time the data coming from the TMP36 sensor, that is a temperature sensor. So we're using it to convert the analogic data that comes from the Vout from the TMP36 to convert it to digital data using the ADC pin right on the GPIO 16, I think. So we're using the from machine import ADC and the pin import ultim. Here we have the initialization of the channel 0 for the ADC. Next we have the conversion factor that is going to convert the analog data to digital data. And we're using the LED to turn on every time our sensor goes to 41 Celsius. So we have an infinite loop that is while true. It's going to read the temperature right from the TMP36. Then it's going to convert it to volts. Then it's going to convert it to temperature. And then it's going to convert it to a string. And right after all that, it's going to print this out on the console, on the shell. If the temperature is bigger than 41, then it's going to turn on the LED. Else, it's going to turn off the LED. So here we're using the same signal to turn on the LED to connect it to the FPGA, so that every time the temperature goes to 41, it sends a 1 to the FPGA, and with that one, the FPGA send a 0 to the relay model, and the internal coil is going to have a lot of electricity and is going to close the circuit. Once the circuit is closed, the electricity and the current is going to flow right into the fan and is going to start working. So when the fan is working, the temperature inside our house that we made is going to get every time lower and lower, and when the temperature is lower than 41, the signal that comes from the LED of the Raspberry Pi Pico on that same GPIO is going to be 0. So uh, it's going to send the 0 right into the FPGA, and the FPGA is going to stop working. So it's going to send a 0 to the relay, it's going to send a 1 to the relay model, and the fan is going to stop getting electricity into the right from the relay model, because the circuit is going to be open. So that's everything. Now I'm going to explain really quick our pin assignments of the pin planner. So we have as input we put the clock in the P11. That's the internal clock of the FPGA. And the reset, we send it to the first switch, the switch number 0, that is the pin C10. And the temperature sensor is the W10. That's the one that we are connecting um, to the Raspberry Pi Pico. And the output is the B10, and that's the fan. Actually, we're using a buffer because the relay model works with negative logic. So it needed a 0 in order for the relay model to close the circuit and start energizing the fan. But whatever the reason, when we sent a 1 to the relay model, it was actually working, so I don't understand quite well, but with the buffer it stopped getting that issue and stopped working and start working correctly. So that's another thing to keep in mind. So we were using the FPGA, the relay model, the buffer, the Raspberry Pi Pico, the TMP36, and the LED.
Well, hello. We have in here the practice where we are going to manipulate the fanning here on the top with the relay that is seen here, that is looks like blue. Here we have the, well, we're not able to see it, but behind that little red cable, let's see if I, that cable over there, we have the temperature sensor that is gonna actually is gonna be read by the Raspberry Pi. That is gonna send the signal whenever we reach the temperature we are looking for to activate the FPGA over there to send the final signal to the fan in here. So, well, to the relay and to the fan. So if we see in here that we actually have a temperature that is going to be given by the Raspberry Pi. We're averaging the 37, 38. We have the temperature set to 41. Whenever it's higher or equal to 41, it's gonna turn on. So if we pump up the temperature with a little friend in here, we're gonna see that the temperature is rising. Whenever it reaches 42, or whatever it is over 41, the little fan in here is already working. So right now we are at 44, 43, 40, 43 and something, and we can actually feel the air coming out from here a little hot, because, well, from here we can feel everything in here going hot because everything else is sealed up. So this little hole we have from the fan works accordingly. So it already reached the 41, 40, and It's because it's like moving around the temperature, turns on and off. We can also see the LED in there that actually tells us whenever it comes up and comes off, comes up and comes off. Because the temperature right now is really, well, hot. It's gonna be doing that until it reaches somewhere around 39 and 40, and I think it's now it's done. It has reached a temperature below 41, and that's it.